The producers and distributors of Tech AV technical training aids welcome you to the second video presentation in the Gas Metal Arc Welding series. During this two-part presentation, you will learn to identify parts and describe their function in a typical Gmaw welding set. You will then learn how to prepare your equipment in readiness for welding operations. As you might expect, there are various types and makes of welding units, each being capable of producing the desired outputs for gas metal arc welding processes. And, for this reason, it is important that you study the manufacturer's manual or operator guide for specific detail regarding your particular equipment. Let us consider first the power source unit. The maximum rated current output of this particular machine is 505 amps. The operator controls on the power source unit are a power switch or on-off control switch, a coarse voltage selector control, and a fine voltage selector control. Other features on the front of the power source include a power warning indicator that illuminates when the machine is switched on, a temperature warning indicator that warns when the unit is overheating, and on this model, a low water warning to warn when the coolant level is too low. These connection points, or tappings, are for the connection of the work lead. Each tapping point offers a degree of inductance in the welding circuit. A further feature on this particular unit is a water reservoir that contains the coolant required for the water-cooled welding gun. Situated at the rear of the power source, we find interconnection points that must be connected to the corresponding connection points at the rear of the wire feeder unit. The wire feeder on this unit is top-mounted on the power source. A feature of this model is that both the wire spool and the drive mechanism are enclosed within a protective housing. Sometimes you will find the wire spool mounted externally. A major disadvantage of this design is that dirt and dust collect on top of the wire, which is then drawn into the wire feeder mechanism. The electrode wire is drawn off the reel and then pushed along to the welding gun by the wire feeder mechanism through the action of drive rolls. On our demonstration unit, there are two sets of drive rolls. A drive roll comprises a pair of grooved wheels that are powered by a small but very powerful electric motor. The motor is activated by the trigger switch in the welding gun. Wire enters the feeder via an inlet wire guide. From here, the wire passes through an intermediate guide before entering the second roll. The wire then passes out of the wire feeder via an outlet guide, from where it moves smoothly on into a wire liner within the welding gun cable. Adjustable tensioners are fitted to the top rolls, and by increasing the tension, the wire can be gripped more securely between the two rolls. Some welding operations, notably aluminium welding, may utilize a push-pull drive mechanism. In this typical example, a second wire feeder is situated within the gun. Such an arrangement is commonly used where soft wire has to be fed through long welding conduits to reduce the risk of wire snagging. Certain operator controls are featured on most wire feeder units. The most prominent operator control is the wire feed speed control. This control is used to accurately set the desired wire feed speed in meters per minute. The other control on the front panel is the trigger mode selector. When set to this symbol, 2T, the gun trigger must be held in the depressed position for welding. When the trigger is released, welding will stop. This position is used for short welding runs. When the selector is set to this position, 4T, activating the gun trigger will start the machine and it will remain operating until the trigger is pressed again. This position is used for long or continuous runs. The final position of the trigger mode switch is the spot weld position. In this position, activating the trigger will result in a short burst of welding lasting a second or two. Also situated on the front panel are the gun cable connecting coupler and the cooling water connections to the welding gun. On this machine, certain controls and setting adjusters are placed inside the wire feeder housing. Depending on the make and model of the machine, you will sometimes find these controls positioned on the front panel. The setting controls featured within the wire feeder housing on our demonstration unit include an inching button, also called a wire jog, a spot weld timer, a post-flow timer for the shielding gas, a burn back control, and a soft start control. Let's look at each of these in turn. The inching button, when pressed, operates the wire feeder, but does not activate the power source. This feature is required primarily to feed the electrode wire to the welding gun when a fresh reel of wire is installed. The spot weld adjuster sets the time duration of the arc-on cycle and is only functional when the trigger mode switch is set to the spot weld position. The shielding gas adjuster is a timer control that adjusts the post-flow time. Post-flow is the flow of gas that continues to pass out of the nozzle after the welding current has stopped. The gas continues to flow onto the weld pool whilst it cools, thus preventing porosity in the weld. The next control is the burn-back timer. Used primarily when welding in the short-circuit transfer mode, this control adjusts the delay time between the stopping of the wire feeder and the cutting out of the welding current. Burn-back is essentially required to prevent the electrode wire from fusing or sticking to the weld pool at the end of a welding run. The last controller on this machine is the soft start. This control is required when the machine is connected to an automatic or robotic welding system. We need not be concerned with it for manual welding purposes. A feature found on many GMAW machines is a purge control. The purpose of this is to remove or purge the air from the gas line before the start of welding. This ensures that only pure welding gas is present when welding begins. Purge control is also used when setting the gas flow rate. Again, it must be remembered that the controls of various makes of machines will differ. For this reason, you are urged to study the operator's guides or manuals relevant to your particular machine. We turn our attention now to welding guns and associated connections. Most GMAW welding guns are permanently attached to the welding gun cable, which, as you will see, is in fact a combination cable, sometimes called a conduit. To be carried to the welding gun and housed within the welding gun cable are the following: the electrode wire, the welding current, shielding gas, electrical signals between the trigger switch and the power source, and, in this instance, cooling water. Welding guns are available in various sizes and duty ranges. Welding guns may be air-cooled, that is, they are kept cool by the atmosphere and the shielding gas flowing through them, or a gun may be water-cooled. All welding guns have a heavily insulated handle to withstand the electrical loads that will pass through it. Situated in the handle is the operating trigger. At the end of the gun is a removable gas nozzle. A gas nozzle directs the shielding gas onto the weld area. Beneath the nozzle you will find a gas diffuser and a contact tip. The contact tip makes electrical contact to the electrode wire. Contact tips, gas diffusers and gas nozzles are replaceable items that become damaged and worn with normal use. Contact tips are made to suit various wire sizes. Shielding gases are stored in specially heavily constructed cylinders, also called gas bottles. The commonest size is this 10 cubic meter bottle, also known as an industrial bottle. The type of gas contained within a cylinder is indicated on a manufacturer's label. At the top of a gas bottle is a hand-operated discharge valve. Note the rugged protection collar surrounding the discharge valve. This collar, which you may not remove, prevents accidental damage to the valve during handling and storage of the cylinder. The pressure within a cylinder, when freshly filled, is around 210 kilograms per square centimeter, and this pressure must be reduced to a working pressure of around 1 kilogram per square centimeter. Pressure reduction is achieved with a regulator, which is fitted to the discharge valve of the gas cylinder. Integral with the regulator is an adjustable flow meter. A flow meter controls the volume or flow of gas being delivered to the gas nozzle. The final component in the welding set is the work lead, also known as a ground lead or earth cable. This work lead completes the electrical path between the power source and the work, and is connected to one of the inductance tappings on the power source. A work lead must be connected to the work or to a metal welding bench with a grounding clamp, such as this crocodile clamp. We have looked at the individual components of a typical GMAW welding station or welding set. In the next part of the program, we will explain and demonstrate how to connect and prepare the components in readiness for use.